Yo, Bytor here. I hope everyone is having a great day. We certainly are now that you are joining us for another interview question. We decided to poll our Reddit community on the topic for today's video. I would call this a tie between op-amps and digital design. So, what we will do today is show you a digital design question, and next week we will follow up with a video on op-amps. A quick side note. We have been getting emails and comments from the community asking us if it's okay for them to share the questions they have been asked or are actively asking during interviews. The answer is absolutely. This is one of the goals we have for our Hardware Ninja community. We strive to have actively involved members who, after interviewing, come back and tell us their story and the questions they were asked. This is extremely important whether you nailed your interview or not, because someone else will likely be asked the same questions you were asked. You can send us an email to the address shown. Let's help each other stand out from the rest. Alright, let's carry on. This next question was prepared by a digital SoC engineer who works in one of the biggest semiconductor companies in the world. You can expect this question as a recent college grad, an intern, or even an experienced designer. Depending on your level of experience, you may be asked this question a bit differently. However, you know Hardware Ninja is all about providing you with real interview questions that have real applications in the workplace. So the interviewer may start with the following open-ended question. Let's say I have a processing unit and it's supposed to talk to several subunits. If I have a stream of bits at the output of the processing unit, how can I make sure that I route the correct information to the correct subunit? I will give you 10 seconds to pause the video and think about your answer. Remember that interviews are not about right or wrong answers. They are about probing your knowledge and understanding how you approach problem solving. So why not go with the most obvious answer? I can always put a mux between the processing unit and the subunits, and I can route the information depending on a select signal from the mux. Before you say, Bytor, you are an idiot for suggesting that, I'm going to preemptively agree with you. There are a number of reasons why using a mux is not a great idea. But this will spark the conversation for you to acquire more information from the interviewer. You can say something like, well, without having all the constraints or all the information necessary, the most obvious and simple solution will be to add a mux and have a mux select signal. I'll leave it as your homework to understand why a mux is not the best solution. Anyway, the interviewer might say, it's a solution, but it's not ideal. Imagine I don't have the bits to spare for the mux select. Although a sort of mux would actually be needed, I agree. What else can you think of? I'm going to give you yet another 10 seconds to pause the video and think about your answer. Well, if the interviewer gave us a clue that a mux-like structure is what we needed, then we need to figure out how to control the mux without dedicated select bits. As a digital designer, you might have already figured it out. But if you haven't, that is okay. That's why we're here. You can tell the interviewer the following. If a mux-like structure is what we need, and the only information we possess is the incoming stream of bits from the processing unit, then it's possible to embed extra information within the string of bits to signal the mux where to direct the data. For example, when our mux structure detects a, let's say, 1010, then it knows to start routing the information to, let's say, subunit 1. When the sequence is, 0101, it knows to stop sending bits to that subunit and is ready for a new sequence to go to other subunits. In this case, each subunit will have its own start and end sequence. If you didn't spell it out for the interviewer already, he might ask, what is this mux-like structure called? The answer, of course, is a sequence detector. The interviewer will follow up with, Alright, so let's draw the state machine for detecting in the sequence, like you mentioned, 1010. Once again, remember that during interviews, people are constantly evaluating how you use your resources and if you seek clarifying information for open-ended questions or requests. In this case, the person interviewing should ask clarifying questions like, would you like to go for a mealy or more state machine? Should we assume overlapping or non-overlapping codes? If you don't ask these clarifying questions, you might arrive to the quote-quote correct answer, but what if that's not what the interviewer was looking for? Then you will only look foolish for making these assumptions. Don't fall for this. Be better than this. For now, let's assume the interviewer said it's an overlapping mealy FSM. I will leave it up to you to build the non-overlapping version and also the Moore variations of both. There are many ways to approach the process of building an FSM, especially if you have plenty of experience. However, we at Hardware Ninja like the following approach. You can tell the interviewer, let me write the input sequence to be detected. To this, let me add 2 random bits to the start and end of the sequence, like so. If this is my input stream, then the output of my sequence detector will be the following. I cannot possibly have a valid sequence until I have 4 bits, so I know during the first 3 bits, the output of my FSM will be 0. At the 4th bit, I can check my sequence. Since it is not what I'm expecting, the output will also be 0. Also, since the FSM is meant to be overlapping, I look at the previous 3 bits plus the incoming one until it matches my sequence, like so. You can always check with the interviewer at this point to make sure you're in the right track. If you are, you can follow up with, now that I know what my output should look like for a given input stream, then we should assign states. Since we are detecting 4 bits, we will need 4 states. Let's call S0 as the nothing seen state, to give a little bit more intuition to what the state means. Let's also call S1 the state where we detected a 1, S2 the state where we detected a 1, 0, and finally S3 the state where we detected a 1, 0, 1. If we start at S0 and our next input is a 0, then we stay at the state. However, if we detect a 1, we can go to the state S1. In both scenarios, the output of the FSM will be 0. At S1, if we detect a 0, we can move to S2 where we said we detected a 1, 0. But if we detect a 1, remember that we said it will be an overlapping FSM. So that means we will stay at state S1 because we detected a 1, or the start of our sequence. Again, in both cases, the output of the FSM will be 0. Looking at S2, if we detect a 1, we will move to S3, or the state that was designed to detect the 1, 0, 1. If we detect a 0 on the other hand, that will destroy our sequence and put us back to square 1, meaning we will go all the way to state 0. Once again, in both cases, the output of the FSM will be 0. Finally, at S3, if we detect a 1, we didn't get the sequence we were looking for, so the output of the FSM will be 0. But the good news is that the 1 we got can be interpreted as the input of our new sequence. So we go to S1 instead of all the way to S0. If at state 3 we get a 0, we complete the sequence and the FSM will output a 1. Again, being an overlapping FSM, we can check what state closely resembles the new sequence 0, 1, 0. In this case, the last 2 bits, 1, 0, correspond to state S2, meaning we're again in the middle of a new sequence. And our FSM is completed. After this, the interviewer will likely follow up with, well, how many flops would I need to implement this FSM? This again will be your homework. We will probably make a follow-up video with the answer to this question if there is enough demand. Let us know in the comments or shoot us an email. And there you have it. Another successful interview question prepared by a real SoC design engineer working in the semiconductor industry. Smash that like and subscribe button if you found this video helpful. Until next time, cheers!